Hello and welcome to Wednesday. This would be April the 15th for you guys. We're going to go to the next section, 8.2, inverses. This is week 3, day 2. Let me change the color here. This. So again, we're going to be going through chapter 8 throughout April. And luckily today is a little bit easier than Monday's lesson when we did composition of functions. This one will be a little bit easier. And then the next week we'll kind of get into how these kind of are related. So today we're going to talk about inverses, and then Monday we talked about composite functions, and then we'll kind of put them together in the next week and kind of how they're related. So today, inverses. Definition of an inverse of a relation. So this is the relation obtained by simply switching the coordinates of each ordered pair in the relation. That's actually all it is. If you have an ordered pair and you want to find the inverse of it, you just switch the ordered pair around. Specifically, you switch the x and y values. So when we have xy and we want to find the inverse of that, we just switch it to yx. And whatever that number combination is, then that's the inverse. We're going to try an example like that. For example 1, got a little bit. So we have let f equal all these ordered pairs. We're going to find the inverse of f. We'll call that inverse g. And then we're actually going to graph both sets. So let's first go through and find the inverse g. G equals the set. So if we go through all of f coordinates, the first one is negative 3, 2. Switch that around. That'd be 2, negative 3. Then you just keep going through the same way. The inverse of negative 1, 4 is 4, negative 1. Keep going, switch that around, 3, 0. This one would be 8, 2, 7, 5, and 8, 7. Oops. Bracket. G is the inverse of f because we switched all the order pairs. Now I'm going to graph both sets. Let's graph G first, and then I'll change the color and graph F. G is 2, negative 3. I hope this works okay. 2, negative 3, 4, negative 1, 3, 0, 8, 2, 7, 5, which would be here, and 8, 7, which would be right here. So this is G. Now let's switch colors, and we'll do the F function. Going through an order and graphing all these ordered pairs, we have negative 3, 2, negative 1, 4, 0, 3, which would be here, 2, 8, 5, 7, and lastly 7, 8. Hopefully I graphed them all correctly. So all of the blue is F. If you look at all those dots, looking at F compared to G, there is some kind of symmetry going on here. And that kind of answers the bottom part here. Notice there's a symmetry line across what specific line? Well, if I actually draw this dashed line, and we've covered this once before, we talked a little bit about inverses. If you draw this line, a diagonal straight through, so if it looks something like this, I'm going to try my best to draw it. this diagonal is the symmetry line. This line right here. So that if you were to fold it on this line, the dots should match up. So if you can kind of see, these dots would match up, these dots would match up, and so on. That's how you know that it actually is the inverse. So if you can draw this symmetry line, this diagonal, and if you were to pretend to fold it on that, they should match up. What is the symmetry line called? So this dashed line that I just drew is called y equals x. That's the graph. Every y value is equal to the same x value, so it goes through 1, 1, 2, 2, 3, 3, and so on. So f is the original, and g is the inverse function. That's how you do it with ordered pairs. Now we're going to switch gears and try it with actual equations and functions, not just having ordered pairs, but it's kind of the same idea. If you go up to the definition, it says this is the relation obtained by switching the coordinates of each ordered pair. If we don't have ordered pairs, we can't switch the numbers, but we can switch something else. Go down to example 2. It says give the equation for the inverse of the following functions, switch x and y, and then what do? We solve for y. So if you look at these ones, they already have y equals on every single set. What we're going to do is switch the x and y variable around. Let's change the color again. How does that color look? Ooh, I don't like that. We're going to switch the x and y around, kind of like we did with the ordered pairs. So literally flip them around. So instead of saying y equals 3x, we're going to write this as x equals 3y. And then it says over here to the right, then solve for your y variable. So y is now over here with a 3. We have to get rid of the 3. How do we do that? Just divide both sides by 3. We're getting y by itself, even though it's on the right-hand side. 3's will cancel. So you actually get x over 3 equals y. I'm just going to rewrite it the other way around. Y equals x over 3. And that's your inverse. So this one up top here is the original function. And then the new one down here would be the inverse. If we were to graph both of these, which we will in a little bit, you'll be able to see that they look symmetric across that diagonal line that I drew up here. Looks symmetric across that line. We're going to try doing some graphing after we do these ones first. On to part B. Do the same steps every single time. We're just going to practice this. Switching the x and the y. So it becomes x equals 5y plus 10. Then solving for y. How do we do that? 2 steps. Got to subtract 10 first. X minus 10 stays there as x minus 10. Then we have 5y. Then we divide both sides by 5. It's pretty important that the 5 goes into both of them, not just the x, not just the negative 10, but both of them. So what would be our final answer? We could write it as y equals, because the 5's cancel. If I want to, I could split it up, or I could leave it like this. It doesn't really matter. I'll split it up this time. So the x could be over 5. And then negative 10 over 5 would be minus 2. So the original is up top. The inverse is in the bottom here. That's your answer. A little easier than Monday, I think. Part C, do the same thing. Switch the x and y. So you have x equals 2y to the third. Now we're going to get y by itself. Got to get rid of the multiplication part. So let's divide by 2. So we have x over 2, doesn't simplify. These cancel, the 2's, and y cubed. How do we get rid of a cubed? How do we get rid of that 3? You can do one of two things. To get rid of the 3, you can do a cube root on both sides, or you can raise it to the 1/3 power. Doesn't really matter. I'm going to try doing 1/3 power. In other words, we also said we raise this to the reciprocal power, so we treat this as a 3 over 1 as a power, then flipped it around and made it 1/3. But then we do that to the other side, to the entire thing on the other side, 1/3. So on the right-hand side, they cancel. And your final answer, y equals We'll leave that as is, x over 2 in parentheses raised to the 1/3 power. All right, part D. 3 more here, and then we'll graph some, and we'll be done. Switch the x and y. Don't forget that first step. It's pretty important. Then we're going to solve for y. Kind of like the same thing we did in the last one. Back in part C, I did 3 over 1 and then flipped it around to 1/3. I'll do the same thing here. Raise both sides to the reciprocal power, which would be 4 over 1. Do that over here. See if I can squeeze that in there. This would end up being just x to the 4th power. 4 over 1 is just 4. These would cancel, the 4s and the 1s. So you could say it's y equals x to the 4th. That's inverse. Part E, switch the x and y. X equals square root of y minus 9. How do we solve this? Add 9 to both sides. X plus 9 equals the square root of y. These will cancel. How do we get rid of a square root? That's the same thing as having the 1/2 power. To get rid of a square root, as if there's like a little 2 here, you have to square both sides. Uh-oh. My pen stopped working. There we go. Square both sides. So as a final answer, this here will cancel each other out, the square root and the squared. So you just get y by itself, which is what we wanted. And then x plus 9 squared would be our inverse. That's it. Last one before we go to graphing, part F. Switch the x and the y. So it'll be x equals y minus 7 over 3. So how do we get rid of the 7 and the 3? First, we probably have to get rid of this fraction. I don't like it being here. Division by 3. To get rid of division by 3, we multiply by 3. You can say it's 3 over 1 if you'd like. We want the 3's to cancel. So we multiply by 3 on this side. We got to do it to this side. Right side will cancel the 3's. No more fraction over there. Left-hand side is just now 3x. 3x equals y minus 7. Last thing we have to do, now we can actually add the 7. Y equals 3x plus 7. If you want to rewrite it with the y on the left-hand side, you can. It doesn't really matter as long as you get the right answer. The last section here, example 3. We're going to graph the above problems, at least A, B, and C. We're not going to do the other 3. We're going to do both the original and the inverse functions. We're going to use the website. So if you don't have a graphing calculator at home, which I don't think anybody really does, I do have a website we can use. It is called desmoz.com/calculator. I will actually put this on Sapphire, so you can just click the link, and then it should take you there. So let's go through and graph the original and the new one on A, B, and C. And then we'll just draw a little sketch at the bottom here. Going back to example 2, so part A is y equals 3x. And then we're also going to put in y equals x over 3. See what it looks like. I'll have to actually type this. Y equals 3x, and it'll graph it immediately. If you want to graph something else, you have to hit enter, and it'll bring you down another thing to type into. Y equals x divided by 3. Now, how did I get that fraction bar? All you have to do is hit the slash button next to the shift bar. So there you can see the original and the inverse, one's in red, one's in black. And the last one I'll do will be the symmetry line that we talked about before, y equals x, just to show you that it's splitting it right down the middle. And maybe I can change the color of that. Okay, well, I don't know how to change the color of that. Thought I could. So the middle one right down here is cutting it right in half. It's a symmetry line, y equals x. I'll keep that one there, but I'm really just going to graph the 3x and the x over 3. So let's just look at those two, and then make a brief sketch of it on our paper. So we have one kind of going, let's see if I can draw this, up like this. Nah, that's not good. It's a little steeper than that. Maybe like this. And the other one is not nearly as steep. Like this. This one was y equals 3x, and this one is y equals x over 3. And then I'll draw that line, the dashed line, to show that it splits it down the middle. Just freehand as best you can. So we have both graphs, and if you were to fold them on that symmetry line, y equals x, they should match up. May not look like it on my screen, but it definitely does on the website. So we're going to delete those two and then just try part B. We're going to put in y equals 5x plus 10 and then y equals x over 5 minus 2. So go back and delete those two. Was it 5x plus 10? That's the first one. Delete this one. So there's 5x plus 10, and the other one is x over, what was it, 2? X over 5 minus 2. There we go. Over 5 minus 2. There you go. And again, I'll put in the y equals x. So you can see it goes right through the middle and cuts it right in half. All right, so as a sketch, go back down here. Let's go and do orange. Looks like it goes right through -2 or so and goes up like that. The other one kind of goes through -2. Okay, it's kind of hard to freehand. Like that. And then again, I'll draw the y equals x as best I can. I can't do it too well. So that's y equals x, and then we have the other two graphs. I'll label them as well. This was 5x plus 10, and this is x over 2 minus, or x over 5. Yeah, x over 5 minus 2. Okay, we got one more to do on the website. Yep, one more. We're going to put in 2x cubed and then x over 2 to the 1/3 power. So let's delete all of these for right now. First one was 2x cubed. And if you don't know how to get a power on there, you have to hold the shift button and press number 6. It's the caret button. Then you hit 3. So it'll automatically put the cursor up there for you to put the 3 there. So there's y equals 2x cubed. We're familiar with what x cubed looks like. And then the other one was, I think we have to put in parentheses, x over 2 and then to the 1/3 power. So parenthesis, x divided by 2, parenthesis, make sure you do the outside parenthesis, so I had to move it over 1. And then we got to raise it to the 1 over 3. 3, there we go. So you can see they kind of cross each other there. And the last thing I'll do is put y equals x. And if you want to, you can actually zoom in on this. Zoom in, zoom out. So you can see it better. So just do a little graph like that, and then we should be done. Let me put that on the other side here. And we'll change the color one more time. Let's do dark blue. So the first one was x equals 2x cubed, which looks not so much like that. A little tighter than that. Maybe something like this going down. And then the other one, I guess, kind of goes like this and cuts down like that. Not too good, I understand, but just a sketch. And then the last part cuts through right through the middle. So it's y equals x. And this first one here was y equals 2x cubed. And the last one is y equals x over 2 to the 1/3 power. And that's it. As long as you can use the website and just draw a sketch, that'll be fine. And as long as you know how to switch the x and y and solve for y, you should be good with that. And the last new thing is just switching the order of pairs, which is probably the easiest part. So hopefully that made some sense and a little easier than the 8.1, the composite functions. And if you have any questions, you can send me a message on Remind or send me an email. And we'll see you next week.